So now this is what we do. Okay, we have this equation, which is rewritten here at the top. And now we do something special. We actually plug in a particular approach, the wave approach. So what we do is we postulate that in this equation there are solutions of the form that the sea level elevation can be described as a constant amplitude times the sine of this argument, and you learned before that this is a wave. It's just a sinusoidal waveform of a wave which has a specific wavelength, which is this lambda here, and the wave which has a specific period, which is the uppercase. So we plug in this approach, okay, but we actually introduce two new unknowns. We don't know what the wavelength is. We don't know what the wave period is. Okay, so if you now plug this into this equation here, and you can do that. Maybe you learned something like that at high school or before. Okay, what do you need to do if you take the derivative of the sine function? What do you get? Okay, you get the cosine function, don't you? Okay. So if there's also something like called the chain rules. You take the derivative with respect to the x direction. You actually have to take the inner derivative of. Anyway, so you can try that and plug in this approach into the equation, and what you get is actually a relation between wavelength and wave period, and this is written down here at the bottom. So what it means, you get that, and this is this is the well-known relationship that the phase speed of the wave is square root g times h. Okay, wow. Okay, g times h. The phase speed of the wave, phase speed is lambda over t, so the wavelength over the period is square root of g times a. What it tells you is there are these waves, okay? They are included in this in this equation, but they have a specific relationship between the wavelength and the only these waves exist with this equation. Okay? So this is what we call the long gravity waves, and you can go into more detail. So now you found a solution for the sea level elevation, and you know that the phase speed has to be square root g times h. But now you can go and plug this into the first equation, into the momentum equation. You get the rest of the solution. Let's do that.